Hey everybody, we are continuing our review of content that we covered prior to going to remote learning. And so we are section 5.3, polynomial functions. The first thing that we're being asked to do is to look at an expression and state the degree and the leading coefficient. If it's not a polynomial in one variable, we're being asked to state why. So if we look at the first example, letter A, we can see that none of the things that make an expression not a polynomial are taking place. And so what we can do is we can rewrite this in standard form, which if you'll recall, means you start with the largest degree and you go in descending order from there. So if we were to do that, we would get negative 4x to the 8th power plus 3x to the 4th plus 6x to the 3rd plus 2x. The degree will come from the largest exponent, and the leading coefficient will come from the coefficient of the term that has the largest degree. So the degree is 8, and I'm abbreviating, the leading coefficient would be negative 4. Moving on to the next expression, we can see right away that this is not a polynomial in one variable simply because there are two variables, both x and y. So we would say no because there are two variables. Lastly, our example here, 5x to the third minus 4 over x squared. This is to serve as a reminder that something is not a polynomial if we have a variable in the denominator of a fraction. And so we are just indicating or writing down that it is not a polynomial because there is a variable in the denominator. Moving on to the next example, what we're going to be doing here is evaluating or substituting expressions into functions. And so what we have here is we're being asked to find f of 3c minus 4 minus 5 times f of c if we have the function f of x equaling x squared plus 2x minus 3. So the first thing I like to do when doing a problem like this is to write the function and insert parentheses where we will be substituting information into the function. So we're being asked to substitute 3c minus 4 into this function, f. So I'm going to substitute 3c minus 4 where there is a variable x in that function. I also need to do 5 times f of c. So here's my minus 5 times, I'm putting parentheses around this entire function f, and I'm going to substitute c where there are instances of the variable x. Now all we need to do is do the algebra and expand, and then ultimately combine like terms. So what I have on the left corner there is simply a reminder that when you're doing 3c minus 4 in parentheses squared, that you need to make sure that you're expanding so that you are performing that correctly. So I'm going to do the math in my head, but this is how you do it. We're drawing your arrows, do your multiplication, and combine your like terms. So we're going to get 9c squared minus 24c plus 16. We're then going to distribute this 2, which is going to give us 6c minus 8, followed by this minus 3. Now, in parentheses, we're just going to get c squared plus 2c minus 3. And it's kind of a silly step to take, but I want to make sure that we have that put into the expression correctly. Now, the next thing that we're going to do is we want to distribute this negative 5 into that set of parentheses on the right-hand side. Remember, when you multiply by a negative number, the sign is going to change. So that's going to give us negative 5c squared minus 10c and plus 15. Once we've done that, all we need to do is combine like terms. So we have a 9c squared minus a 5c squared, which gives us 4c squared. I'm going to cross them out as I go just to keep track. What I now have is minus 24c plus 6c, which is equal to negative 18c minus 10c. So that would be negative 28c. Lastly, we're just going to combine all the constants. 16 minus 8 is equal to 8, minus 3 is equal to 5, and plus 15 is equal to 20.